Hey, today we're going to do a virtual lab about acids and bases. So you have this Google Doc right here on the assignment, and you're going to turn this in when you're finished. The first thing you're going to do is you have to read the instructions very carefully. So the first thing is we click on this website, and it says we're going to click Introduction to begin. So I'm going to press play, and I'm going to click Introduction. Okay, now it says the lab tool has three things. We have a pH probe, pH paper, and a circuit with a battery. This tool is used to test conductivity. So we're going to describe the brightness. So let me do water with you. So the first thing we want to do, we're testing out water. So I'm going to select water. Let's see if we've got water. See, water is selected right here. The first thing I want is the value from the pH probe. So I'm going to, the pH probe down there, the value is 7. So I want to type in a 7 right there. Now I want the color from the pH paper. So I'll take my pH paper at the bottom, I'll put it down in there, and I'll see that it's orange. So I'm going to type orange in there. And then I want my observations for the circuit tool to describe the brightness. So my circuit tool is right here. When I put it in water, it's very dim. Okay, so we're going to put very dim. Okay, so what I want you to do is I want you to do that same thing for strong acid, weak acid. Remember, you come right here to do strong acid, strong base, weak base. If you forget how to test those things, go back, pause this video, and go back. All right, now we're going to look at what are the pH values for acids and what are the pH values for bases. Well, we know that if we take our pH probe into a weak base, it's 9.5, a strong base is 12. Our acids are low, they're below 7, and water is right at 7. So our acids would be 0 to 6.9, and our bases would be 7.1 to 14, because 7 is right in the middle. So why are some solutions a better conductor than others? Well, you can see our weak base is, if we put our conductivity tool, our weak base is sort of bright, but look at our strong base. And then our weak acid is sort of bright, but look at our strong acid. So when you're looking at what makes things a better conductor, it's how many ions are in the solution. Because if we look right here, you can see there's a lot more ions broken down in a strong acid than a weak acid. All right, so the parts of the chemical equation, it says highlight the portion that tells you if it's an acid, a base, or neutral. So you know that, look, when we have this acid, we have H3O+. When we have a base, we have OH-. So I know if I see OH-, that's going to be a base. If I see H3O+, that's an acid. But look right here, we know water is right in the middle, and it's got both. So you would highlight those, and I'm going to do it in yellow. Right here, we see H3O+, that must be an acid. So I'm going to highlight in yellow. I see OH-, that must be a base. I'm going to highlight in yellow. Okay, now we're going to go and click My Solutions at the bottom of the simulator. Okay, so I know you can't see this, but at the bottom right here, we have My Solutions. So you're going to click on My Solution. Okay, I'm going to retract this up a little bit. You're going to click on My Solution. It says, what does the strength slider affect? Well, when I make it stronger, I see a lot more ions. So I have more ions in solution. Now it says place the pH probe in the solution, change the strength, and see what happens to the pH. So it says this is going to be for acids. So we have our acid. Notice up here I've selected acid. I'm going to stick my pH probe in there. The stronger I get, the lower I get. The weaker the acid, the higher the number. So if I'm going to put stronger acids equal closer to 7. Weaker acids equal closer, stronger acids are closer to 0. Weaker acids are closer to 7. Because notice when we are weak, we are closer to 7. All right. Now it says, what do you notice in the picture of the ions and molecules? When we're weak, not many ions. But when I change it to strong, we have lots of ions. Stronger acids have more ions. Now, you're going to do, it says repeat the sim, place the pH probe, change the initial concentration, and see what happens. So we're going to change the concentration now. What do we notice? When we are more concentrated, we have a lower pH. If we have more ions, we have a lower pH and a stronger acid. And when we got more concentrated, look, we have a lot more ions. We have more ions in solution. So it says compare the difference between the number of ions and molecules using the strength slider. Explain the difference between the pH and the number of ions. So when we have more ions, we have a lower pH. We have less ions, we have a higher pH. So it says compare the difference between the number of ions and molecules using the strength slider and using the initial concentration. Explain the difference between the pH range and the number of ions. We know that if there's more ions, we're going to have a lower pH if it's an acid. And we know that if we have less ions, it's going to be a higher pH, closer to 7. So does this support the fact that dissociation or splitting apart of ions is what causes a solution to be considered strong or weak? Yes, because when we are strong and we have a high concentration, we have lots of ions, lots of dissociation going on. Okay, and then lastly, you are going to do this. Now, on my computer, it's not going to let me show you because I don't have Adobe, but what I want you to do is on yours, go through all the way to challenge 3 and type the answers. All right?